All right, so now we're going to extend our probability that we've been learning about. So this one we're first going to go over is called the multiplication rules. And it's two different events that we want to look at. It's one where we have independent events, and then another one where we have dependent events. All right, remember, I'm going to go through this kind of quickly because we're going to start going through all these in class anyway. The first one we're going to look at is independent events, and you need to be able to identify when an event is independent or when it's dependent. When it's independent, the first thing that we're looking at, so the fact of A, so two events A and B, A has no effect on the probability of B occurring. So one of the things that we're going to discuss in a second, or that they do here, is if you flip a coin, we can get heads or tails. And then if we roll a dice, we can get 1, 2, 3, 4, 5, or 6. If we do these two events together and we're looking to see what's the probability of getting a heads and a 1, regardless if we flip a heads or a tails, or if we roll 1, 2, 3, 4, 5, 6, the flipping of a coin and the rolling of the dice have no interaction. They have no effect. There's nothing that happens between them at all. So they're independent. And when we're looking for independent events, it's really easy when we're trying to find what's the probability of both occurring, the probability of A and B. Is we find the probability of the first event, the probability of the second event, and we just simply multiply them together. So it's actually pretty easy to solving these. So when we're going through, we need to ask ourselves, does the first event affect the other? Or is the first event, will this change the probability, the odds of the second event happening? It's one of the ways you can ask as well. Or are they independent? Do they have no bearing on each other whatsoever? Flipping a coin and rolling a dice, they don't affect each other. And when they don't, you just simply multiply the two together. Right, now this was the exact same scenario I was just talking about. They're doing two events. A coin is flipped and then a die is rolled. So we ask ourselves, do they affect one another? Are they dependent or are they independent? Well, they are independent because whether or not we flip a heads or a tails, it does not affect what we can get on our dice. So for this one, if we want to find the probability of getting a heads, well, the probability of getting a heads is 1 out of 2. And that's the key here, and the probability of getting a 4 and a die. So then we will multiply our two events together, and getting a 4 and a die is 1 out of 6. So the probability of getting a heads and a 4, if we were to flip a coin and then roll a dice, it will be 1 out of 12. So we have the probability of getting a 1 out of 12 that we would flip a coin and then roll a dice, and we would get in heads and a 4 and a die. And one of the key things here that we're looking at is now we're looking for the probability of A and B. The last section we're working on, we're doing the probability of A or B, and that's where we're just adding them together. Here, when we're trying to find both, we need to multiply them. All right, but remember, you need to ask yourselves, is this dependent or independent? The next one says a card is drawn from a deck and replaced. All right, that's a key word that you need to see here. Later on, when we start doing dependent, the cards will not be replaced. It will be drawing a deck of cards and then drawing another card from the same deck without replacing it. And since we're not replacing it, the number of cards that we have changes. It goes from 52 to 51. Well, here, since it's replacing, the number of total cards that we're picking from never changes. So that tells us, this word replace, tells us that these are independent. And then the second card is drawn. Find the probability of getting a queen and then an ace. Well, there are 4 queens in the deck of cards with 52 cards. If we pick one, we have the probability of getting a 4 out of 52 or a 1 out of 13 of getting a queen. And then the probability of getting an ace, well, since we're putting that card back, we still have 52 cards here. So we can do the probability of getting an ace is also 4 out of 52 because there's 4 aces. So that also reduces to 1 out of 13. We multiply these two together, it will be 1 out of 169. All right, the next type of events that we're going to look at now are dependent events. So when the outcome or an occurrence of the first event affects the outcome or occurrence of the second event in such a way that the probability is changed. All right, so if it changes the probability, meaning if we have a bag of marbles and there's a red, blue, and white marble in it. Well, if I say, what's the probability of picking a red first? So then we would have 1 out of 3. And then if I say, well, what's the probability of picking a blue after that? And we don't put the red marble back in. Well, now there's only 2 marbles left over and 1 blue. So the probability changes. So this would be a dependent event since picking the red marble and not replacing it will change the probability of picking a blue marble. All right. So before an answer to a question can be given, you must realize that the events are dependent. So when you're given a question, you need to ask yourself, are they dependent or independent? So what I was saying to you before is if someone selects an ace on the first draw, that's 4 out of 52. But if we do not replace that card this time, then there's only going to be 51 cards left over, and the probability of getting a king on the next hand is a 4 out of 51 because there's 4 kings and 51 cards remaining. So not replacing the card affects that event, the second event. That makes it dependent on the first one. All right, now we're going to go over a list of some dependent events or dependent events that you will see pretty frequently. All right, so some common examples of dependent events is drawing a card from a deck and not replacing it and then drawing a second card. So that's why you need to see, are they replacing it or not? Selecting a ball from an urn, not replacing it, and then selecting a second ball. The total number of balls that we have in that urn would change because we never put it back. Being a lifeguard and getting a suntan because you're out in the sun, so this getting a suntan could be dependent on the lifeguard. Having high grades and getting a scholarship. So getting a scholarship is dependent on high grades. You need to get good grades if you want to get an academic scholarship. Parking in a no parking zone and getting a parking ticket. Well, if you're going to park in a no parking zone, chances are you're going to get a ticket for it. So that's why this parking ticket is going to be dependent upon if you're parking in a no parking zone. You can also have other examples of where you could get a parking ticket, but it's just showing you that this is dependent if you're going to be parking there. All right, so when we're finding the probabilities that events are dependent, it's actually very similar to the first one where they're independent, that we're going to be multiplying the two events together. The problem is, or the difference is, when the second event is dependent, it's no longer going to be the same denominator or the same probability. Like here, if we're drawing a probability of drawing an ace and then a king, well, it's 4 out of 52 for the ace and then 4 out of 51 because we removed one card from the deck for a king. And so it's not exactly the same like the one before. So it is slightly different because we're now multiplying the two events just like the first one, but now we're multiplying a different probability for the second one because it's affected by the first event. So when they're dependent, the multiplication rule with a modification in notation. So for the problem just discussed about the ace and the king, the second one now has a different probability. So the event of getting a king on the second draw, given that an ace was on a first draw, is called conditional probability. This is something we're going to go over the next day in class, but just remember this. When we're talking about conditional probability, it's where we are looking for an event happening, so a king being drawn on the second time, given, that's the key thing. So conditional, it's we're given that the first event was taking place. All right, so that's going to be on the next video, though, not for this one. All right, so when we're looking at the events of dependent, the formula for it is the probability of A multiplied by the probability of B given A. That's what that line means. That's how it's read. The probability of B given A, meaning when they're dependent upon each other, we're going to then act as if the event A did take place, or in some cases, it's just saying, like in this case, a person owns a collection of 30 CDs. Of which 5 are country music. If 2 CDs are selected at random, find a probability that both are country music. So when we first look, well, we have 30 CDs, so we know the first one's going to be over 30 because that's what we're picking. 5 are country. So that means our first time that we're doing this is 5 out of 30 or 1 out of 6 odds of picking a country CD. Well, now when you pick the second one, so now we're looking for the first event happening, but we're picking a CD and we're wanting both to be country. So now we're looking, well, that means probability of B given A, meaning that we're looking for the first one was a country CD. So we're only looking for that example where it's country, which means we have 4 country CDs left over. And now since we took a CD out, we now have 29 there. So it'd be 1/6 times 29, which is then going to be equal to 174. So it'll be 1 over 174. So the odds of you picking country music, if there's 5 of them out of the 30 CDs, the odds of you picking 2 country music CDs in a row is 1 out of 74. 1 out of 174. All right, now there's just a couple more examples I'm going to go through. So here, 3 cards are drawn from an ordinary deck and not replaced. It's a key word that lets us know then that they are dependent. Find the probabilities of these events. A, getting 3 jacks. So in our first time, we know that we have a 4 out of 52 chance of getting 1 jack. The second time, we have 3 jacks left over because we want 3 jacks in a row out of 51 cards. Then the third event that would happen will be now we have 2 jacks out of 50 cards. So I'm going to reduce these first. It'll be 1 out of 13 times 3 out of 51 times 1 out of 25. Now, the reason why I'm reducing these first is if I reduce my fractions first, it's not going to give me, I won't have to reduce them at the end. So 13 times 51 times 25 is equal to 16,575. And 1 times 3 times 1 is equal to 3. And that means we have a 3 out of 16,575 chance of picking 3 jacks in a row, which is not very good. That, as a percentage, is equal to 0.0181% chance of getting 2 jacks in a row. All right, so the odds of getting an ace, a king, and a queen in order. So that means our first event would be an ace, will be 4 out of 52. Our second event would be a king, which would then be 4 out of 51. And our third event, a queen, would then be 4 out of 50 because we're picking an ace first, then a king, then a queen. And our cards are going down because we're not replacing them. So this would then be 1 out of 13 times 4 out of 51. And this reduces to 2 out of 25. All right, so now we multiply across. We know 13 times 51 times 25 is going to give me 16,575 because we just did that. And now we have 4 times 2, which is 8. So the odds of getting an ace and then a king and then a queen in order is 8 out of 16,575. All right, for C, we're looking for the odds of getting a club, a spade, and a heart in order. Well, club, we know we have 13 out of 52. Then after we pick one card and we don't replace it, it's now going to be out of 51. Well, we still have 13 spades, and then we will still have 13 hearts, but now it'll be out of 50. All right, so then this one will reduce to 1 over 4, and the others I don't believe reduce. They do not. So then we multiply across. 4 times 51 times 50 is going to be equal to 10,200. And 13 times 13 is 169. So that's the odds of picking a club, a spade, and then a heart in order. And then the odds of getting 3 clubs. Well, our first one is 13 out of 52. Well, now we would have picked a club, so we'd only have 12 left out of 51. And then our third one, we would only have 11 left out of 50. All right, when we multiply, this would then be 1 over 4. So it'll be 1 over 4 times 12 over 51 times 11 over 50. Well, we already know that 4 times 51 times 50, as we did here, is equal to 10,200. And now 12 times 11 is going to be 132. So the odds of picking 3 clubs in a row is 132 out of 10,200. All right, there's one more question, and then that's it. And this is all we're going to go over in class. So you can skip. I'm going to put it so you can skip through the video, but it's there for you if you need it. All right, the last question. This one's a little bit trickier. So here we have box 1 contains 2 red balls, 1 blue ball. Box 2 contains 3 blue balls, 1 red ball. A coin is tossed. If it falls heads, box 1 is selected, and a ball is drawn. If it falls tails, box 2 is selected, and a ball is drawn. Find a probability of selecting a red ball, period. So normally you would think that flipping a coin and picking balls out of a box, that they're independent, that they can't affect one another. But since it tells us if we flip a heads or a tails, it changes which box we're picking out of. That makes it dependent of each other. So when we go to do our first coin flip, we can either get a heads or a tails. All right, and the probability of getting a heads is 1 out of 2, and the probability of getting a tails is 1 out of 2. And now if we get a heads, that tells us that we're selecting from box 1. Well, there's only 2 different kinds of balls in box 1. It is a red or a blue ball. Now from here, the probability of getting a red ball, because we have 2 and there's 1 blue, that means 2/3 of getting a red ball. The probability of getting a blue ball is 1/3. So if we flip heads and then won a red ball, the probability of this occurring, well, we have 2 events, flipping a coin. Well, the heads is 1 out of 2. And then the event of getting a red ball is 2 out of 3. So that means we would multiply these 2 together. So the odds of getting the odds of flipping a heads and then getting a red, that will then give me 2 out of 6, or it can reduce to 1 out of 3. All right, so that's one event that can take place. So if we flip a heads and then get a red ball, we have a 1/3 chance when we flip a heads and getting a red ball. Now we need to look for the tails. Well, once again, once we flip tails, we have 2 different chances, a red or a blue. In this case, though, we have box 2 contains 3 blue balls and 1 red. So that means red is only 1 out of 4, and blue is 3 out of 4. So once again, our tails is 1/2, and then our red balls is 1/4. So that means the odds of getting a tails and a red ball is 1/8. So these are the 2 events, getting 1/3 and 1/8. Well, these are our 2 events where this could happen or this could happen. So now since it's one or the other, we need to add them. So when we add these, we can add our two events, so 1/3 plus 1/8. Well, we would need to multiply this by, let's see, we need to go to 24 as our common, so it would be 8/8. And we will multiply this one by, 3/3 to get 24. So now we will get 8/24 plus 3/24, which is then equal to 11/24. So overall, even though there's multiple things happening here, two different events that can take place, since we add them together, we have 11 out of 24 chance of getting a red ball. All right, that is it for this video.